to another session of Introduction to JavaScript. This is just to give you for the new viewers who are coming in, just to give a brief introduction of what we are doing over here. So Newton School has launched this new program called Launchpad, in which we are actually trying to provide education to everybody who wants to who has very little or no experience with JavaScript. So this is the course that we are taking up right now. And 1 second, I think I have some issue. Hello, everyone. Sorry to be interrupted last time. So basically, I was just giving you an introduction what this Launchpad program is. So basically, Launchpad is a program by Newton School in which we are wherein people with no or very little experience in programming can come up and they can come up and start learning about programming. There are a lot of courses that are available. They're like Introduction to Java, Introduction to Python, Introduction to JavaScript. We are currently the one that we are taking up today is Introduction to JavaScript by Anirudh Agarwal. If you go on the dashboard, you would be able to see all of those courses available. In the previous lectures, we have talked about what JavaScript is, how it is different from other programming languages like Java and Python, and we have covered what is a function, why is it called a functional programming language, what is a constructor, what are static functions, what are non-static functions. All of that we have already covered. So you are most welcome to go through all the courses that are there, all the videos and all the lectures that have been recorded, and they are available on the place on the website. So today we are going to be covering. So last time we had talked about what a class is, what are the variables, what are data members, what are member variables, member functions, what are static member functions, what is the need of a class, and all of those things, right? So today what we are going to be covering is, so we've seen basically how object oriented programming works, and then these are all the principles that are there consistent for all the programming languages. So it's basically it's a part of programming and not something which is very particular to JavaScript. So so today we are just going to be putting it in more formal terms, so that it is easier for you to understand and it is easier for you to explain to others, and so that is what we are going to be doing. So when we say class and then we define a variable inside a class, what does this actually mean, and all of that. So if you want to go through all the lessons, I'm not sure why this is not loading up properly. Let me try to. Okay, probably we can come back to this later. So for now, what we have done, what we had discussed last time, we'll quickly go through what we had discussed last time, and then probably we'll see what is it that we are going to be covering. So basically, if you want to define a class, so basically, what is a class? A class is a template of an object. That is what we have been talking about. So if you want to create multiple objects and with different values assigned, and I told you, like, object is basically whenever you create an object of a class, it's basically creating multiple containers of a class, right? So whenever I define a class and I create a new constructor and I do use a new variable, basically what it does is it calls the constructor and creates an object of this particular class, wherein it creates a container of this class in which there will be data members of like a name. This container it would have its own name, it would have its own data variable called copies, and then similarly, when we do a new and when we do book two, it would create another container it will create another container in which there will be a new memory allocated for this particular data member called name, and another for copies. So that is what object, or that is why it's called. So it creates an object. That's why it's called object-oriented programming, right? And today what we are going to be covering is that we are going to be putting it in formal terms. So basically, what do we do? What do we do when we say? So let me just try to zoom it a little. Cool. So basically, when we say when we define some of the things inside a class, what does it actually mean? It means that we are actually trying to encapsulate some piece. I think we had talked about this in brief, but today we are going to be putting it in formal terms, wherein what basically encapsulation means, right? So what basically encapsulation means is that we will whenever we are creating an object, right? When we create an object, so basically whenever we are creating a container, we try to put different variables. So so going back to the example that we have been talking about, so if there's a book where we have been talking about library management system, so please refer to the previous lectures to get a context around what this class is and why is this used. So basically, whenever I create a new, whenever I do a new book, whenever I do a new book or whenever I do a new book with algos and 90, what this guy does is that it basically what this will do is that it creates a container, and it assigns these properties, right? So name and copies will be within this container. When I do a new, like whenever I create another object of this class, it will create another copy, like it will create name and copies, and this particular the value that was saved against the name field in this container would be different from the memory that is allocated, would be different for this particular container. So basically there are, so this is so you can think about that, you can think of it as that the data members are encapsulated within an object, right? It's something, so this particular object has nothing to do with whatever is happening inside this particular object, right? All the data members, whatever is happening inside this particular object has nothing to do with this particular guy, right? And multiple copies. So if you think about it, and if in general terms, what would encapsulation mean? It's basically creating a capsule. And when I was learning programming, I remember how my teacher used to explain it to me was that so basically what do we do, right? We when we send space missions, right? What is it that we do? We send space capsules, if you would have known, and or you can Google it, right? So basically what do we do is we generally send space capsules into space, right? Which means that, and what do we put in those space capsules? We put in some information about humankind, about animal life, about marine life, so that if and we release it into the space, right? Whenever a rocket goes into the space and we release it into the space, and how does that help us? How it helps us is that if there exists another life, right, in space, if somebody is able to access apart from Earth, if life exists, so they would be able to retrieve that information, and they would know, right, that what is happening, like that there is another life which is present in this universe, right? And what all information have we put in the capsule? We have tried to put in information which is related to our Earth, right? And similarly, so that is called a capsule, that's called space capsule. And similarly, if you think about it, a class is an encapsulation. It is a capsule which is containing some information about that particular class. And that is the object oriented programming. There's a very famous saying that a class should only be concerned with what it is doing and not concerned about anything else, right? So a book should only be concerned about what is the name of the book, what are the number of copies in of the book, and various properties that are related to just the book. And it should not contain information about the library or information about the students. It should only consist of, and that is called your design patterns, right? This is when we go to, when we try to build scalable solutions, what is it that we do? What is it that we are trying to do? What we are trying to do is that we are trying to encapsulate our data in such a way that it is more scalable in that fashion, right? Whenever I create a class called book, I try to put in data members inside it called name and called copies, and then I also assigned, we also talked about that there can be multiple functions, and these functions are also related to only the book, right? It has nothing to do, and it should not contain any functions which is not related to the book. It would not make any sense for us, right? So that is what we are doing, right? We created a function called increment book count, in which we were able to increment the count that was there. So if a student returns a book, we would increment. So the number of, so basically there's a book called algos, in which if a student returns the book, we'll just call this function increment book count, and without knowing what is the underlying implementation of the class, we would be able to play around with the data of the class, and whatever data is encapsulated within the class. So that is why it is called data encapsulation, and we'll come to the formal definition of it, and which means that encapsulation is the concept of bundling of data related variables, right, properties and method in one class. And that is what we have been talking about, that we actually just want to encapsulate all of it in one go, right? And encapsulation approach of restricting direct access of to the some data structure elements, fields, properties, methods, and etc., right? And how would you restrict that, right? So we will come to that, and let me just first talk about that. What is it that, why is there a need to restrict, right? So talking about the why that we have been talking about, that whenever we are learning something, it's a very good practice to understand the whys, right? That why do we need something. So just talking about that, what is it that we want to do? Why is it that, so basically, why is it that we want to restrict something? So in this particular copies, right now, basically copies is something which should only be accessible by the class itself, like this particular data variable, right, data member of the class. So ideally I should never be able to do something of this sort, right? Where once my book variable or my book object has been created, I should not be able to do book1 dot copy is equal to 500, right? So this is not correct design, right? Because this is not which is expected. This is something which is not expected by. Let me just try to put it here. Yes. So why am I saying this is something which is not expected? Is that you should not be able to access, you should not, this is not correct, right? That you should not be able to directly modify the number of copies. The only thing that we should be able to do is that if you want, so basically if you want to know the number of books available, what we should do is that we would write a getter function for this. So what we'll do is that get number of books, that is what we'll do. And what we'll do is return this dot copies, and that is what we will do, right? And now whenever we want to know the number of, so if I want to know that if what is the number of books that are available, we'll go get number of books, and that is what, that's it, right? We should not be, and there should not be any setter function for it. So it should only be created, so number of copies should be created only at the time of creation of a book, right? And if you want to update, this, basically what would I want is that you delete the existing book, and you remove it. And if a student returns a book, or if he issues a book, you can call the increment and the decrement book count methods respectively. So, but you should not be able to access these variables. You should not be able to access these variables outside the class. So to do that, what is it that we do, right? JavaScript provides us a functionality called declaring a function as private, right? So let me see, what does it say? Okay, so basically, yes. So you cannot. Basically, what we want to do is that this is we want to define it as private, right? And how would I go about defining a variable as private? So private is something which exists as a object oriented programming paradigm. It is not something which JavaScript internally supports, and that is why I put it this way, that uh, basically what is it that I am trying to explain is that private is that there are some variables that need to be private, but JavaScript in itself does not provide us that functionality. So this is one difference that comes in with using JavaScript as a object oriented programming language. So this is one challenge that comes in, and I hope that in the coming versions of JavaScript, this problem will be solved, right? So now, if you see in industry, there's a superset of JavaScript called TypeScript, which provides. So it's a TypeScript is basically a language which is open source, created by Microsoft, which is written on top of JavaScript. And everything that is written in TypeScript is can be compiled directly into JavaScript. And what it does is that it provides us all of these neat functionalities of putting private and all of that, right? So basically, if you talk about object-oriented programming, and not JavaScript in particular, but if you talk about object-oriented programming, what basically it means is that we would want to restrict some direct access. We would want to restrict direct access to these data members. We do, and we should not, and in JavaScript we should not be doing book1 dot copies equal to something. This is not something which is acceptable, right? And that is what we have been doing. So usually you would see, right, in production level codes and in bigger programs, you would see that all of these variables are never accessed like this. You would see that all of these variables, right, book not dot name, book dot copies is not accessed directly. It basically, you would always create getter functions and setter functions. So these are, and for also the name of the book, we'll say get name, right? And basically this is what we will do, and it will do return this dot name. So basically we've tried to restrict that. That is, we've encapsulated all of these values, and we have tried to restrict direct access to the data member. So usually it is a very good practice to not give direct access to your variable. So and the reason for this, right? This question is asked a lot, right? In interviews, in a lot of questions, that why, and this is the question which would come directly to your mind also, right? Since you're seeing it for the first time, that why is a getter function required? I can just do book1 dot name, right? So the reason is that the reason is that, let's say today you have written this function, but going forward, what you want to do is that you want to put in some logic around this. What you want to do, you want to append this book, something like this, before the name of the book. You always want to do this, right? I'm just giving you an example, a random arbitrary example, but this is something which is a genuine ask. This could be possible, right? So that then at any point of time, wherever in your code, wherever you are doing, what would you have to do is that wherever you would have done book1 dot name, what is it that we would have to do, right? So we would have to go, and we would have to write this, right? Book. And this is something which we would have to do, but this is something which I do not want to do, right? This is my code duplication, and the concept of functions and classes and object creations and new constructor, all of this came because I did not want to write a lot of code. I wanted to make my code more scalable, and that is why we would not be doing this, and that is why we generally use getters and setter functions. Similarly, if you want to do if you want to put a setter function for name, and basically, and it would take some string, and let's say name. So basically what you can do is that you can put this check, right? If name is equal to empty, then you can throw some error, right? And you can say throw not valid name, right? This basically throws an error. We will be covering these are basically advanced JavaScript concepts, and we will be covering those at later point of time. But for now, this is basically how we will actually throw errors, and this would not set, and otherwise, and you can do a else loop and say that this dot name equal to name. So this is something which is a good practice, right? So you can put in validations. So all of this can be built. That's the use of getters and setters while using data members, and not providing direct access to your data members of your class. So that is what this is all about, right? Going ahead, the next concept that we are going to be talking about is abstraction. So you would have seen me talking about abstraction, what abstraction is, what is the process of data abstraction, and how and you would have seen me that I have cleanly abstracted my code. I'm not able to this particular variable is not able to access this particular variable. This has nothing to do with this. When I was talking about the concept of classes, I talked about what is data abstraction, how when we're implementing a class it helps in data abstraction. So that is what we are talking about, and we are trying to put it in formal terms. So what by definition, what does it mean? Data abstraction is the process of hiding certain details and showing only essential information to the user, right? And that is what all of a class is about, right? And if you talk about it, I have abstracted this logic of setting and getting the name of the book, and I have abstracted this logic of not providing a setter for the number of copies. I've abstracted that, so that my data doesn't go corrupt, and somebody who's using my book class is not able to directly play around with the copies variable. They are not able to play around with the particular copies variable, and they are just able to do increment and decrement of the book count, right? So that is what this is all about. And I'll try to explain it with this example. It's a very neat example, right? So when just talking about the person, and there's a job, right? And we talked about, if you're talking about a company, right? And if you're talking about a company, so we'll create a class called person, and we'll create a class called job, right? And in that job, so a person called, we can name it Victor, John, Roger, right? Whatever name it is. So this particular person, Victor, has first name, he has last name, he has some skills, and he has a job, right? And that particular, now we could have, what we could have done is, right, what we could have done is that we could have put all of these company, position, salary inside this particular itself, like, right? So skills, and then we could have company, position, and salary. But this is not a good practice. So if you remember, the first statement that we talked about was that a class should only be responsible for what it a class should only have those fields for what it is responsible for, and not anything else. That is what data abstraction is all about. Data abstraction is basically a person is there, and what is it that and we have tried to abstract. What we've done is that we've tried to abstract the job part of the person into another class, right? And this what this particular person object is doing, that it is holding a reference to the object, to another object of job type. So basically, if I try to put it in this way, and just to give you an example of what a person, what I mean. So if I, let's say, person one, and what does it mean is that this person has a first name, and let's say this guy's name is let's say John, and his last name is Victor. And then what else? We had some skills, and we'll create we'll say that it's an array of, let's say, he knows JavaScript, he knows Java, my bad, Java, and let's say he knows Python, right? And then let's say he also is holding a reference to job variable, in which it's an object, right? And that particular object now has, he's holding a reference to another object which is of job type. So let's say I create another variable called variable job one, which holds some values, right? Which holds value of, let's say, company, and this, I could put in another variable called Newton School, and then position and salary, right? So let's say I say position, let's say ABC, whatever, right? We are not concerned. And salary is, let's say, we'll put it as we'll put salary as 100, right? Whatever, right? It does not matter. Cool. Right. So basically, this is a variable, and now this particular person is now holding a reference to another class, another object, which is job one. And that is exactly how it looks like. This is exactly how it looks like. Otherwise, what we could have done is that we could have taken all of these values, and we could have put it in this way, right? We could have done this, and this makes sense. But what we have done is we have abstracted out whatever is not related to this person. We have abstracted out to a job object, and we have been able to, and we have put it there, and we have created a reference to that particular object here, right? So now, and let's see how when we're creating a class, how would we do that, right? So let's say I create a class, and we'll say job, and in this job we will have a constructor, obviously, to create. And just to remind you that creating constructor is not mandatory, but it is in any logic that we want to do at any logic that we want to put at a class initialization time, we would put it at in constructor, right? And we can do all of these things. This dot company equal to company, this dot position equal to position, my bad, this dot salary equal to salary, right? And this is exactly what we'll do. And let's not get concerned with creating getters and setters for this, and we'll create another class called person, right? Class person. And what we will do is that we will assign all of these variables again. So first name, last name, oops, skills, and job, right? So job is there, skills is there, then we have last name, then we have first name, right? My bad. And then we'll define a constructor, and we'll put all of these values, right? We'll put first name, we'll put last name, we'll put skills, and we'll put job. So similarly, we can do this dot first name equal to first name, this dot, and this is a very common practice, right? And I'm not doing something which is exceptional. This kind of code you would see in most of the classes that are holding the data, right? This is basically called these are called data classes, and because they're holding data, right? They're holding data related to a person, they're holding data related to a job, all of these, right? So these are called data classes, and this is a very common this thing that you would see for this is very common uh, thing that you would generally see around, right? And so now whenever we are creating a person object, right, we have to pass it a job object, right? So first what we would have to do is that we would have to create another variable. We'll have to create a variable of job job of let's say of we'll say Newton School. So any person who's working in Newton, who's working as an employee in Newton School can be assigned this particular object, or let's say any or just to define it a little better, any person who has the same salary as all the people who have the same salary, who share the same position and work for the same company, can be assigned this particular object. So that is what we'll do new job, and we'll say company name we can give Newton School, right? Then what we'll say is the position we can say as let's say we'll give as manager, or let's give it ABC, and then we'll say salary as 100, right? And then whenever we're creating a person object, it's as simple as assigning this particular variable, right? New person, and we can say John is the name of that person. We'll say Victor is the name of this particular his last name. We can give anything, right? It does not matter, right? And we'll give some skills, let's say JavaScript, and we'll say Java. And now we want to pass, right? So we'll put job Newton School, right? And that is what we'll do. And let's just also log this guy. So console.log of person1, and we'll see what happens, right? And let me just remove everything else, and let me try to run. There's some issue going on. We'll see how fast it runs. Yes, exactly. So this is what. So basically, when it creates an object called person, and that object contains first name, last name, skills, and then job contains another class. It is another object of type job in which it has three values all of this, right? Whatever we had created, Newton School, position ABC, and a salary of 100, right? So that is what we had done, right? We had done this. So we have created an object of job which contained these values. So think about it. So let's try to visualize what is happening, right? So basically, what did we do when we created this job Newton School object, right? What did we do? We created a container of type job in which there were three variables. What were the three variables? Company name, position, and salary. So this container got created in memory. Sorry. And then what did we do? Then we created another object of person type, and it created another container. Think about it. And this container now has a first name, has a variable called first name. It has a container of last name, and then it has some skills. And then basically what it does, it would not have this container as is, right? What generally how JavaScript works is it works as by pointing as use something called as references, right? So basically what it would do is that it has a reference. So when we do, when this job, right, and this job, right, this dot job or dot job, this dot job equal to job, right? When we did this, so basically what did it do? It basically created a reference to this particular job object. So this is my container, my person container, this is my job container, and this particular job data member has created a reference. So it is actually, if you see it, and that is how it is represented, that it is actually represented as an arrow. It is represented as an arrow for and it's known as a pointer or a reference variable. So this particular job, right, it's a reference variable. So and whenever we want to refer something from the job, we'll do person.job.company, right? So this is what we are doing. So basically what it is doing is, so we talked about addresses, right? So now in a house there is another. So let's think of it as a house which has another house inside it, or you can think about it as a apartment complex, right? So this person is basically an apartment complex in which there are multiple apartments, and the name of the apartments are like first name, last name, skills, job. And so basically job in itself has another apart and and job is basically an apartment in which there are multiple rooms there. You can think of it as rooms, and the name of the rooms are company, position, salary. So if you want to go to a particular apartment, you want to go to a particular room, what you would have to do is that you will go to the apartment, tell the apartment that, okay, I want to go to your job apartment. So it'll take you to the job apartment by doing a dot operator, reference operator, and then what it will do is that it will go to the room, then it will dot company, so it will go to that particular company. So that's how it is, right? So that is what your abstraction is, right? So you have abstracted out the logic, you've taken out the logic. You don't want to put everything, you don't want to overload a class, you want to take out, you want to keep your class as small as possible, as concrete as possible. And so basically what when I say you want to keep your class as concrete as possible, right? So what would happen is that the point of creating a small class is that if you want to change some logic around your job class, right? So then how that benefits is that you are not touching your person class, you are only touching your job class, you're never touching your person class. And that is what we always aim for, that whenever you're touching your code, right, whenever let's say, imagine this code has been running for a year, right, and a new developer comes in, and he does some other changes. Now what you would have to test all of the changes, right? So if he says that he only made some changes to the job class, so now you would be focusing only on the job class. But if you and you would only have to check for these three variables whenever you're testing your code, right? You would have to only check for only these three variables. But let's say these variables were a part of your person class. So now what you would have to do is you would have to check for all these three, and then you would have to check for these three, right? So just so you would actually be testing for, basically you would be testing for six variables. So that is not something which we don't want. So that is where your data abstraction comes in, and there are multiple benefits to having data abstraction in our code, right? So that this is all about data abstraction. If you have any doubts, please use the doubts forum and do let us know. We will cover a lot of things, right? We can cover a lot of other concepts, right? So we'll come to the next topic, which is inheritance in JavaScript. And this is like one of my favorite jokes, and I have always picked it up. Like, what does inheritance mean? Inheritance means that whenever you inherit something, right? So when you inherit genes, when I was born, I inherited some qualities from my father, right? And let's say you people say that so generally it's referred, right? So there are some people who are in general very pretty, or it is about hair, right? That your hair are very long and thick, right? So all of this comes from genes, right? And this is, and when people ask that, it is all inherited. Like, I inherited this from my father, right? So there's a joke said, what is the object oriented way of getting rich? It is inheritance. That if you inherit everything from your parents, and if you inherit something from somebody, that then you can get rich, right? So that's the joke. So that is exactly, and that is what we will also be covering. So this same principle applies in case of classes also, right? And just talking about it, what does that mean, right? So let's say I take a class, right? And I create a class called car, right? And we've talked about this. We've taken this example before. And what does a car do, right? So basically, a car moves, right? And let's say I create a function called move, and it would have some logic around how car moves and all of that. For us, for the sake of simplicity, because I don't know, I'm not an automobile engineer, so just for the sake of simplicity, what we are going to be doing is I'll just print console.log, and I'll say car is moving, right? I'll just do this simply, right? Now, and then there will be something as stop, and they'll create a function called, we'll say console.log of car stopped, right? Now think about it, let's think that there's a car, right? And this is a car, and there are multiple types of car, right? We talked about that there are economical cars which give very good average. There are sports cars which do not concern about average, but they give very good acceleration. And then there might be some cars. There are cars which we are developing, which we can move on water, and there are cars which are flying also. So let's just to keep it very interesting, I'll try to take an example of a flying car, right? So let's say I try flying car, right? I'm trying to develop something called as a flying car, right? Now what I'll do is that I'll need my flying car would move, my flying car would have to stop, and my flying car would also have to fly, right? So basically it would have something, a fly function. And again, I don't know how a car flies. So what I'll do is I'll just console.log, and I'll say car is flying, right? This is a very hypothetical example. Please don't. That's just to keep things interesting. That is why we take an example of flying car, right? Now, if you think about it, and then we can take another example of, let's say, class, and we'll say race car, in which sorry, my bad. In this, it would not have the fly function, but instead it basically would have a function called accelerate, right? Because acceleration, uh, because race cars need a lot of acceleration, right? So we'll say accelerating, yes, right? So that is what we will say, that the car is moving, car is stopped, and So now if you think about it, all of this code, right, and all of that we're talking about object-oriented programming and all of that, and the use of functions and everything is just to remove your code duplication, right? And so so basically what we can do is that we can say this particular flying car can can be a child of car, and it can inherit, move, and stop properties from its parent, and only put and only have only those properties which are limited to itself, right? So by that I mean that this can it can actually inherit these two functions, which are move and stop, and it can only have this particular function. It can, because this is the function which is only limited to this particular flying car, and no other type of flying car will have this, right? So what we can do is that we can remove these two, and what we can do is that we can do extends car, and that is it. That's exactly, and that's as simple as that, right? So JavaScript, and this concept is again, this is a concept which is an object-oriented programming concept, and not limited to just JavaScript in particular, right? In Java also, it's exactly the same. It's the same as writing extends, right? And basically, what does it do is that a car, now when I do this, right? So I when let's just to show you, what we'll do is that we'll create flying car one, and we'll do new flying car, and we'll do flying car one dot. Now if you see, right, it is giving me all of these functions, and when I do all of this, so basically even though this class does not have these functions, it basically is allowing me to call, and I'll try to run this, and car stopped, right? So basically it actually inherited this particular function from this particular class. This flying car inherited it from the car as a parent class, and then it was able to, and then basically when we called the stop function, it called the car stopped function, and it printed the car stopped function, right? So if you think, and just to give and just to put it more formally, and just to give it some few names, the class that we are inheriting from is called a parent class. The class that is inheriting from the parent is called the child class, and there's an extends keyword. This is again a reserved keyword by JavaScript. And that's it, right? So and also so we talked about functions, right? Now what happens in case of data members, right? So let's say you have we define something as car max speed, right? And we give it 100. Let's say, let's just, and basically all of these data members also would be inherited by the parent, by the child class. So that is how it is, right? All of the data members are also inherited by the child class, right? And there is, now we'll come to the concept called multiple inheritance, right? So multi-level and multiple inheritance. No, we will talk about what multiple is, what we'll talk about what multi-level is. Just to give you an example of what multi-level inheritance would look like is, let's say, we'll go to the year 2050, in which we are having races with flying cars, right? And now we can say that race flying car, just to give you an example. And now in this case, what we would need is that we would need the fly function of a flying car, and we would also need acceleration in flying mode, right? So we'll need that, right? So what we can do is, instead of actually extending from the parent from car, and then again write a function called fly, what we can do is that instead of doing that, what we can do is we can directly extend from flying car, and then we can do so basically, now what this guy will do is, it will have this move function, it will have this stop function, it will also have this fly function. Now what we can do is that we can do flying acceleration. So, and we can do console.log is of flying. That is what we can just do, right? And then now this particular class will have reference to all the members of this particular class. So its parent is flying car, and then this parents, and there is another class which is here, right? So it will have this has properties of all its parents, which is this, and then this has the now rate line car has properties of this class, its parent class, plus the parent of its parent class. So it will have all of these properties inherited inside it. So this is called multi-level inheritance, wherein inheritance is happening at multiple levels. So that is how it is, right? Now thinking about now let's think about we will just take an example of we'll just take an example of how this is run. So if we are saying race flying car, and now we can call fly, and this is exactly how it will work. And instead of just doing this, we'll just do console, or it won't print. Yep. So we can do and we can run this guy. I think there's some issue. Cool. Yes, it worked, right? So it says flying acceleration, right? So that is exactly how what is it? That's exactly what we wanted, right? That we created multiple level of inheritance, right? And this is exactly how it is. Now we one more concept that I want to talk about is the case of constructors, right? And what happens in case of so when I do a new flying race car, which constructor will be called, right? Only this class constructor will be called, but what if there are some initializations that are happening in the constructor of this parent class, and what if some initializations are happening? So let's say we can do this, right? And let's say in this constructor, and this speed, right, was getting assigned in the constructor of this class. So this dot car max speed equal to 100, right? So let's say I was doing this, right? We do initializations in our constructor. Uh, and when I do FC1 and when I try to run and I do console.log of FC1 dot car max speed, what would happen, right? That's what I want to know. So ideally, it should give me a value of 100. I think there is some issue going on, but yeah, eventually it will work. Uh, 1 second. Yeah. Uh, Yeah. So basically, when we see that we are able to print this value of 100, right? So but how did this happen? We have not written anything. We have not written the constructor in this particular class, and still this particular thing gets initialized. So now the concept with object-oriented programming, and again this is a concept which is applicable to all the concepts, all the programming languages, and this is the object-oriented way of doing things, is that whenever we create a parent class, whenever we create an object, right? So what happens is that it will go to the first parent, right? With whatever is the first parent. So basically, car has a constructor. So first its constructor would be called, and then its child's constructor will be called, and then at the end will be the constructor called of its child. So we just to see this in action, what we'll do is we'll do console.log of car, and then let's just also define a constructor here quickly, and we'll do console.log of flying car, And here also constructor of console.log of race flying car, and we'll see this in action. I think there is some it'll take some time. So the concept that I'm coming to is this is called this concept of one constructor, the parent constructor getting called, then its child constructor, and all of the constructors that are getting called is called constructor chaining, and that is how JavaScript has been designed, right? So now going to this is how what it means by inheritance in JavaScript, right? uh, Again, one more concept that I wanted to cover, which is very famous, and it is also related to object oriented programming in particular, and not just JavaScript, is called polymorphism, wherein what polymorphism means is that what basically what polymorphism means is that it means one name and many forms. So one very stupid example, but I still remember it when I was learning JavaScript, when I was learning about object-oriented programming, which my teacher gave it to me, was that when we use an air conditioner, think of an air conditioner, right? And what is an air conditioner? What does it do? It has a compressor. It takes in hot air, and it produces cold air. So whenever you are using an air conditioner, what do you do, right? What do? You take in you take you the side that is pointing towards the room is actually the side which is actually the side that is actually pointing towards the room is the one which is throwing out cold air, right? And now if you imagine, very stupid again, but it will help you remember it, that is why I'm giving it. But let's say in case of winters, right, what if you invert the air conditioner? So in that case, what would happen? It throws out hot air, right? It throws out hot air from its backside, and it throws out cold air from its front side, right? So if you invert it, what would happen? It can work as a heater also. If you think about it, I'm not saying it's a very good example, but still, right? If you think about it, it can work as a heater also, right? Because it throws out hot air from behind and cold air from the front, right? And if you invert it, it can work as a heater. So that is what it is. So air conditioner. So the name is so it what it means is, and we can say it is one name and many forms. So that is exactly what it is doing. It has just one name, but it has multiple forms, right? And that is exactly what polymorphism means. So in JavaScript, since it's not a statically typed language, basically what it means is that the arguments that you provide, or the parameters of a function, do not have a type. So it does not matter how you would go about polymorphism, how you would go about implementing polymorphism at compile time, right? So in general, when you talk about object oriented programming, the two concepts that are there, there are usually two types of polymorphisms. One is compile time polymorphism, another is runtime polymorphism. What compile time polymorphism means is that when a function, let's say we'll take an example of a function, and what basically it means is, we'll remove all of this. My bad. And what we'll say is that we'll create a class, and we'll name it a car. And let's say I'll create car, and then move, right? And let's just, for the sake of simplicity, we'll move it. Name it as this move, right? And let's say it is taking a variable x, right? And again, if we want to define another constructor, or let me remove this, and we'll say we'll just keep another function, and we'll name the function as add, right? And this is exactly what we'll do. And in this add, we can say x and y, right? And what it will do is it will return x plus y. That's it, right? And what we'll do, console.log, and we'll call add function, and we'll put it 1 and 2, right? And we will try to run this particular piece of code, and we'll see what happens. Right? It might take some time again, just to run this thing. But if you think about it, right? So basically, this particular function add, what is it doing? What is it doing, right? So basically, if I had given it a value of 1 and 2, and now let's say I give it a value of let's say a comma b, right? And I'll put it strings a comma value of strings b, right? So this is exactly what we want to do, right? And now what would happen is that it will run the, and it will just this output of this will be 1 plus 2, which will be 3, and this output of this will be ab, right? And if you think about it, JavaScript is intelligent enough and it does not have types. So basically JavaScript is intelligent enough just to understand that, and this is exactly what we see. JavaScript is intelligent enough to understand that this is what we have been, this is what that we want to do, right? And when we do plus, right, it is figuring out that the strings would have to be added, in a way wherein it would have to be put one after the other. But if you pass it as numbers or integers, what would have to happen is that it would have to add, right? So 1 plus 2 should be added as 3, right? So this is exactly what JavaScript is doing for us, right? And you can think of it, this also is a kind of polymorphism, right? So this function has only one name, which is add, but it has many forms, right? It is able to add integers, it is able to add strings, right? So it has it and if you pass it some double values or some other values, right? So it is able to do all of that. So that is why we call it one name, many forms, right? Now if you think about it, the example that we had taken before, right? Let's say we'll take an example of class and we'll say car, and let's say uh, let's just say that okay, and we'll define a function called run. In this, it says that running, and we'll do running, and let's say I define a class base car and extends car, right? And now if we want to say, and let's say there are multiple other properties, right? Let's say there are multiple other properties to this particular class, and we want to inherit all of those properties. But this particular function, right, when a race car is running, I want to actually, instead of this particular run, right, or whatever run mechanism is running, we are just consoling it, right? So let's say I want to console.log of, and I want to say running very fast. So let's just take that, and let's say we want to, and we'll also take, and since a truck usually runs slow, so what we will do, running slow but steady, right? Let's say we want to do this, right? Now what is it that we are doing, right? So what is it that JavaScript is doing? So basically when it goes, right, when it sees that there is a run function, and this run function is also present in its parent, when a run function is also present in its parent, what generally it does is that it actually runs this particular function, and when this is happening, what it is doing is it's overriding the method body. So instead of this getting run, instead of this printing running, it would print running very fast. And the reason for that is that this is called method overriding. Why it's called method overriding is because it has overridden the behavior. Whatever behavior was provided by the run functionality of the car is now actually overridden by the run functionality of the race car or the child class. And that is what polymorphism is. That it has now, what we can say is that it has one name, but it has many forms, and depending on which kind of a class it is, depending on which kind of a child it is, it can actually go ahead and we can give some different implementations to that particular function. So that is exactly what it is. This called polymorphism, and that's what we've given in the example also, that vehicle, if let's say there's a vehicle or a car, and there's a vehicle which has a function called run, and in that oops, my bad. Yes, and there's a vehicle called run, and in that there are two classes, car and truck, and in that there are two functions, run and truck also has this run function. So whatever implementation is provided by the car's run function will can be different from the implementation provided by truck's run function. So that is what that's the difference between these two, and this all of this, right? When we do a new uh, race car, so all of this, so basically when JavaScript sees this, and first it will go to its parent, that is how we have seen this, and it will run its constructor, and then it will see that what all functions are there in this, and then it will see that okay, race car is there, and then it will see all of its functions, then it will see that okay, run function is also present in the car function, in the car also. So basically what it will do is that it figured this out at runtime, and that is why this is called runtime polymorphism. And we'll talk about this later, tomorrow, tomorrow in detail in the next session. But so that I just wanted to give you what is polymorphism, and we'll talk about use cases of polymorphism in the next session. That is all for today. Thank you everyone for joining in, and please do, if you have any doubts, please do use the doubts forum, and let us know how we can help you or how we can do better. Thank you. This was Anirudh Agarwal. Thank you.